Hey, Matt,
Hey, Mike.
would you like to do a podcast?
Yes.
All right, let's open up this box on containerization.
Sure,
Welcome.
that worked.
Worked. Air quotes. Welcome to Hacking the Grepson, the podcast where we do silly things. I'm
Is that
here.
our new tagline?
Sure. I'm here. My name is Mike. I'm here as always with Matt, and we thought we would do something a little in the box because usually we're always doing quite out of the box thinking and talking, but we're gonna go in the box today and talk about containerization, which is a long word to basically yeah. Why isn't it just called box computing? I mean, that's really what we're talking about. Is we're like
We're going to
putting
be talking about boxing today.
I mean, it's not Boxing Day, so it seems a little
Right.
inappropriate. But
Yeah. Well, I honor Saint Boxing on all days.
okay, well that's because you're a true acolyte. um, so containerization, what does that mean? To go right to the source of all human knowledge, Wikipedia. It says that containerization is operating system level virtualization or application level virtualization. Other words, other words, other words. Basically, I think the key word there is virtualization. And
Yeah.
I mean, I think essentially what they're talking about, containerization is, normally when you think about a computer, like the computer that, I'm recording this on right now, there's like this physical object with, the hard drive and the CPU and everything and a monitor that I'm, interacting and keyboard and mouse and all that kind of stuff. Um, that's fine for a lot of applications, but when you just want to run a service by itself and you don't need to interact with it on a daily basis like we're doing right now, you might think about virtualizing it.
And I think it's worth calling out the distinction between the different types of,
Yes, please.
like, you were starting at the bare metal kind of like hardware,
Yeah.
right? And that's what most people think of with a computer. You've got your operating system installed on your computer. You load up your computer and use what you have is what you do,
Hmm.
right? There's not anything more to it.
Right.
But like you and I were talking about playing video games earlier, and some game, and like I'm on a Mac,
I'm
and
also on
some
a Mac,
games
yes.
do not run on my Mac.
Right.
So you might run a virtual machine on your computer that acts like another piece of hardware that you load the operating system and everything else on. And that was kind of the standard for a long time. So I know with Mac they had, what was it, Parallels, I think was their virtualization software.
Yeah.
There's VirtualBox, all those.
There's also
all
just
those different things.
Crossover, which was like
Oh, I
a
haven't used that one.
yeah, Crossover was like a GUI front end to I think Wine, which is like
Mm.
Wine isn't something
So Windows
emulator.
emulator to begin with.
Yeah, yeah, which is essentially like I want to run Windows stuff on my Mac, but I don't want to like type stuff into a terminal, so I use something called Crossover. But yeah, no, go ahead.
Oh, yeah.
You were in mid thought, I assume.
I don't know. My brain shorted out. It happens. The virtual machine in my brain shut down, and I had to go back to the bare metal. Yeah. So you've got that, right? You've got your standard computer. You've got your virtual system, which it tends to be running on your actual computer and just like loads a different operating system.
Hmm.
I used containers, or not containers. I used virtual machines a lot back when I was developing on a Unix machine, or Linux machine technically, and I was building Windows applications, and vice versa, right? I've also worked on Windows machines and been building things that needed to run on Linux, and so I would load Linux in a virtual machine.
Right. Wait,
Um,
Linux or new Linux? It's very important you make that distinction.
Wait, what's new Linux? This is new to me.
No, no, no. Oh, sorry, GNU.
Oh, GNU.
Yeah,
GNU's not Unix.
right. But
Yeah.
GNU slash
Yeah.
Linux is different from Linux, according to one person in the internet, at least. Mr. Stallman.
Oh, yeah. Stallman would make that
He
distinction.
would, yes.
So yes, running GNU Linux probably technically, given that it had all the new tools in it.
Hmm.
Yeah, so that was kind of the standard for ages. I mean, I imagine when you were coming up in the IT world and programming stuff as well, that you also went through that kind of evolution in working with your machine.
I did, yeah. Uh, as more of a web developer, I whatever OS my machine that I was interacting with was running, if I wanted to test it, say on like Internet Explorer, if I was on Mac and I wanted to test Internet Explorer, which only ran on Windows, you could have a whole nother machine, a whole nother bare metal machine running Windows and open up your web browser and test it. But that's a whole nother machine you got to have. So yeah, running like VMware or VirtualBox to create a virtual Windows install that I could just open up to check Internet Explorer on my web project to see if it worked. Yeah, I definitely remember doing that.
Did you ever dual boot?
I have dual booted. I have dual booted Mac and Windows on the same machine.
I feel like that was the precursor to virtual machines for me. Was okay. I've got my one computer, and now I'm going to partition the hard drive so that I can do Windows over here and some other operating system over there,
Right.
usually
And
Linux.
and and that and that was better because before that, I probably literally had two machines and I used a
Yep,
KVM switch
yep.
and hit a button and it's like, okay, now I'm on Windows, boop, now I'm back on Mac or whatever. Yeah.
So it was like so that's the evolution. You got your actual computer, you got multiple computers, then you can combine those multiple computers into one thing
Hmm.
with dual booting. But then you can only have one open at a time. Then you've got your virtual machines that let you run effectively your other partition on your machine, so you could actually have them both open on the same machine at the same time.
Hmm.
And then that brings us, I believe, to containers.
I believe so. And I'm glad you did that history. That was really helpful to kind of put it all into context. And I'm trying to think of like what what would you say the difference is between using, and we'll just throw this out here because I think this is the word that most people know about, Docker, which is a very popular containerization software that essentially lets you write a config file that says like give me this operating system, install these things on it, and then once it's up and running, run a command, and you type that on a command line and you wait, and then bam, you have that system running on your system. But you're not using VMware, you're not using VirtualBox, you're not using Crossover or Wine or anything like that. So what is the difference between that and what we just talked about?
So if you leave the thing up all the time, there's functionally no difference between running a container that you never shut down and a virtual machine.
Hmm.
The big difference is the way it's actually used, which is, as with most computers, you will bring them up and shut them down. A virtual machine it has file storage and all sorts of things stored within the virtual image, I guess. I don't know what they call that.
Yeah.
Um, and so, you boot up your machine in a virtual machine, you do stuff, and then you shut it down. When you boot that back up, it's still there.
Hmm.
With a container, that's not true because now you've taken that operating system effectively and you've made a base image, which is the thing that you're loading. You load an image of a machine. It's like a snapshot of a
Hmm.
virtual machine at a certain time, is the easiest way to think about it. The technology underneath that's a little different, but basically that's what it is. And so every time you load it, you are loading effectively a fresh clone
Hmm.
of when you first built the image. I use this all the time. It's becoming more and more popular.
What do you generally use it for?
Well, originally, when I would use this, I think I mentioned earlier having to load different virtual machines in order to do like software development,
Hmm.
and in particular, like cross compiling to a different operating system than what you have was difficult to do. With a container, I would my first use of a container was I believe it was a Linux image, and what I would do is I would actually launch my compile in the container. So it
Hmm.
would build on the on my target operating system, even though I was running like a Mac or something locally.
Hmm.
And so it would act like it was running on that other system. I had a local directory mounted to that so that my file changes were in fact stored so they didn't just go away. But that way that everything came out with the right um, binary format and everything else. So that's a very common usage. And I think nowadays it's more often used for building or running those kind of systems when you're basically anything that's like an ephemeral task. Like I'm gonna do a thing and then I'm gonna shut down. Containers are a great fit for that.
Yeah, that sounds right. I think my first foray into Docker was we were starting a project at my job that used and this is actually kind of jumping ahead a little bit because we were using a part of Docker called Docker Compose,
Hmm.
which is for bringing up multiple Dockers. And so when you think about a website and you think about all the resources that a website uses, you might have a front end project, you might have the back end processing, you might have a database, you might have a user authentication endpoint or something like that. And so you can manually say, Docker load front end, Docker load back end, Docker load database, et cetera, et cetera. Or you can write a Docker compose file that has all of these projects. And so you hit one command and they all come up. And so it's like, oh, normally on the remote server part of this where the actual project is running that actual people are using, but we want to develop it locally first. We need to have the same kind of setup, but I don't want to have to spin up 4 servers to run all of those components. So instead, I make Docker files for each of those and then a Docker compose file. I run one command, they all come up, I do my stuff, I bring them all down.
And running multiple machines like that is a lot more feasible these days with multi-core machines and all this extra memory because you're still using all the resources.
Right.
And in fact, with containers and virtual machines both, you're dedicating resources
Right.
to these images so that they're running, using using what you already have on your machine. But with multi-core, multi-CPU, lots of RAM, you're actually able to do that and spin up like 4 servers at once to test out what you want. That's really cool. I used Docker Compose very, very little at one point, and I was really only using it for to short circuit some of the more difficult things that you have to do in Docker directly. It was a little easier to do in Docker Compose, but I was only spinning up one image at a time still.
Yeah. We also have used Docker Swarm, which is
I haven't
essentially
used that one.
the clustering
Hmm.
part of Docker. So, like if we had a database cluster that we wanted to spin up and spin down, you would use that for that. So, I mean, that's largely what I've used containerization for is just working on these web projects that have multiple components and need to be spun up. But it's funny because you were saying how like Docker and containerization is maybe more so used for ephemeral tasks, whereas I feel like I use them like virtual machines. It's just instead of having to create, 4 or 5 virtual machines that I have to go and install the operating system and set them up, et cetera, and then install all the stuff on them and then bring them all up. Like I write a file and I run a command and all of that stuff happens and then I can bring it all down. But I usually leave it open all day because I often don't shut them down for multiple days because it's like I just have all of these environments running concurrently. And yes, as you said, this is possible because of my local computer getting a lot more RAM, so I can run all these things constantly. And yeah, so I couldn't have done this, probably 10 years ago, because the resources just weren't there. But now we all have very, you know, capable machines, so I can do that kind of thing. And I think I've gotten so used to it that I don't think about how amazing that is and how undoable that was not that long ago. So,
Yeah, it's pretty crazy.
yeah.
Let me ask: Are the servers that you're running when you do that most of them running the same like operating system underneath, like the same version of Linux or whatever,
I believe so,
or
yeah.
do you have completely different? Yeah, because that's another great place where containerization really shines in my mind
Mm.
is because when you're building your Docker image, you have layers, like an ogre or an onion. Um, uh,
That's a nice
you have
Docker.
layers
I
involved.
like that Docker.
And so when you're building a container, the container is built out of multiple layers.
Mhm.
So usually you'll have like your base operating system or your base image is just like a clean operating
Yeah,
system
and the
with like
bare
nothing on
minimum
it other than like,
to run it, yeah.
yeah, it's like it's got like apt-get and things that you need to install other
An
things, and
LS.
that's about it.
Good enough.
Right. And then you would have a layer that would, for example, copy all the files that you need to run onto there. Or in the case of like if you're running multiple web servers, you might have the next layer being like install Apache or whatever,
Right.
and then you might have multiple things that are just loading individual files or whatever. And the nice thing about that is then you don't have to reinstall the like you were saying with a virtual machine. You'd open that up initially to create that virtual machine. You have to go on, install the actual operating system,
Hmm.
and you would have had to do that for every single server you want to do this for. Now you can just say, "Yeah, I want Red Hat 7,"
Right.
or whatever, and then you have it magically because they've already put out a container.
Right. Yeah. You were mentioning before how like the initial kind of configuration is that image, which says like I want this image. It's sort of like a recipe, like I
Yeah,
I want this kind of cake with this kind of ingredients, and make a clone of that, like, and now I have a clone of that running, and I can make another clone. I can take that clone down and bring it back up, and it's all done from like a single config file, and there's no other app running, like you said, that you have to install the things, and once it creates that container, that's the other thing is once it creates a clone of that, it just brings that back up, so you don't have to recreate the clone every time. It's just there, ready to come up and go down to do the thing you need to do. One of the first things I said, though, from the Wikipedia was that containerization can refer to operating system level virtualization, which is what I feel like we're largely talking about, but also application level virtualization. And something that I have not had a lot of experience with, but when I was doing the advent of code in Python, I ran into an issue with dependencies, like system level versus the app, like the app I'm running. And so I tried to figure out a VENV for Python, which is apparently
hmm
very common when you start up a project. You create a virtual environment, and then that has all the dependencies for that project, and it doesn't touch the system, which seems very similar to this Docker, except just for Python. But I feel like you probably have a better take on how that works because you've had more experience. So can you kind of discuss the differences between those?
I can try.
Okay. Well, that's all I ask, Matt.
I actually would say that the VENV, the virtual environment, is probably closer in practice to a virtual machine than to a container.
Okay.
Like at least from my perspective, because I am doing things like, all right, I'm spinning up a new virtual environment for this Python project, and now I'm going to run pip install
Mm-hmm.
blah 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 blah, right? And so I've now effectively built a virtual machine, a virtual environment,
Yes.
literally,
Yeah.
for that. So it's like, okay, instead of installing this Python package globally, I'm installing it locally, and I'm running this version of Python, and I'm doing this, and so I'm very much establishing that. Where that kind of crosses over with containerization, at least from my perspective or my experience, is you can often use that, like the concept of virtual environment, and and load that into a container. So like you'll have like your requirements.txt file or whatever it is, and it'll know, oh, I want to install all these things in a virtual environment on this container, and then run it. And that's what you'll see behind the scenes. And I don't think this is actually necessarily true, but if I was going to build a something like AWS Lambda, right, that lets you run, these very micro functions, right,
Right.
that like spin up, do a thing, and shut
And that's
down.
that's Amazon Web
Um,
Services, right? Which is like cloud
yes,
computing, like make a server in the cloud.
yeah, it's behind the scenes of a lot of the things that you use, probably.
Yeah.
Um, but if I was going to build AWS Lambda, I would probably use containers, certainly to start,
Yeah.
because then you could take exactly that, and that's what I did, or that's what it would be if you ran a Python Lambda, not to be confused with the Lambda function in
Mm-hmm.
Python, but similar concept. Um, it would just upload basically that env file, and then run your function inside the container.
Right.
So you basically select, I want to run this Python container, and then here's my package of stuff to load on it, and then it just runs it. And so the only thing that you're adding is that layer that is your code,
Right.
and the rest of the stack is all the same thing. And then it just executes.
As we're talking about Python's virtual environment system, it's reminding me a lot of the Node JS system,
Yes.
uh, and
They
and
have a very similar
and
concept.
the infamous Node underscore modules directory, which even for a hello world node project is often hundreds of megabytes of dependencies, which could be a whole nother podcast discussion. But it's a similar idea in that when you're running different projects on one machine, you need some way to kind of segment them, and your system, like the machine you're running all of your code on, might have a version of a node dependency that's version 1.2. But for your project, you have to have 1.3, but you don't want to overwrite what's on the system because something else might be using that, or maybe multiple people are using this system. And so you just want, containerization is really like a way of segmenting a thing, a service, a project, an app in its own little environment so that it's running what it needs and it doesn't step on the toes of the global system. Or even more so, like maybe like you said, you create a virtual machine of an operating system that you don't have running. You're on Mac, but you need to run Linux or you need to run Windows. It's perfect for that. But even if you don't need another OS, you just need version 1.3 of a dependency that's different from 1.2. And or like this happens a lot, not only in Node but in I think one of the first times I ran into it was with Ruby. Ruby
Mhm.
has quite a ecosystem, not just in its dependencies, but even just in the version of Ruby you're running. I mean, and I know Python has had a similar thing between like
Yeah.
Python 2 and 3 was a huge upheaval. But like, yeah, Ruby, just the difference between, 2.1 and 2.2 could have completely different dependencies that have different requirements, and you need to be able to compartmentalize them. And so something like containerization, either at the operating system level, which is a little overkill, but the application level is kind of the node modules, the whatever composer with PHP I use a lot. They have the same thing, like they have a vendor directory where you install just the specific versions of things for your project and you don't touch the global state. That's an important thing to have, because messing with global state, I mean, there's always a thing in programming where don't use global variables. It's the same with your system. Don't try not to use global stuff if you can, help it, because you do run into more problems that way.
Thanks for that segue, by the way.
Oh, you're
Uh,
welcome.
that's what I was going to talk. What I was going to talk about was having effectively a clean system, right?
Clean.
Restarting to a
That
clean
sounds
state,
nice.
and that when you talk about global variables, one of the reasons that global variables are can be painful
You were gonna
is
say are
because
bad.
someone else can just go change it,
Yeah.
right? Right? Some other part of the code that you didn't think about can go change the state. Well, the nice thing about a container is you're usually running, in fact, you are running a process within that container.
Right.
You can do more things, but it's complicated to do that. So one of the main places I've used containers in the past has been in building out a CI/CD system. So we'll have like, okay, this is what our build machine looks like. It's got these things installed. It's got this version of Python or whatever, right? It's got this version of that, this version of that, and it's established. And everything that we're going to build is going to build on that machine. So I have a consistent, clean platform to build on.
Right.
I've taken that a step further on some systems that had a lot of files, or in the case of like JavaScript development, where node modules is huge and it takes forever to do the
Hmm.
install. Like I have some projects that'll take like 3-4 minutes to do it, just to do the install, because it takes so long to pull down all the dependencies.
Yeah.
So you can, and I have built containers that have that stuff on
Yeah.
it. So it's like, okay, I've got my system installed now. This thing that takes forever and it's multiple gigabytes, and all right, all that application is now installed, and now I can run it. So I can do all my testing in a clean environment. It's like, okay, do all the build my image, and now that image is used in every single stage of my CI/CD system to do all of my unit testing. And if I want to do like a type check or lint, I can do all that on that system, and I get this consistent results. And bonus, since those things tend to run off in like the cloud somewhere, if you run into problems with it, you can then download that image and run that command directly
Mm-hmm.
on your machine. So I use that a lot in debugging CI/CD systems that I helped other teams build.
Yeah. We also use a little CI CD when we're pushing changes to certain projects. It'll run a bunch of tests on some cloud area. And yeah, and I have also had to do that where I have to, because it fails on the CI/CD, and then I have to pull it locally, and I realize something about the image that's weird that I would not have noticed otherwise. So yeah, I feel like it's not a hot take to say that containerization is was like a huge paradigm shift to the way that everybody work. Like, I feel like I've been doing it for so long that I don't even think about it anymore. But before this, it feels like so many of the things that we take for granted now were so much harder and onerous to do. And maybe people just didn't do them as much. And like the way that you can start a project and start testing it across different platforms is so much easier now that it was not always like that. And I feel like my career has kind of coincided a lot with containerization, so it feels normal. But like if I were doing my job, 30, 40 years ago, it would have been very different, I think. I don't know. What do you think, Matt?
I think for sure, it's simplified a lot of the problems. I remember back when I was a system administrator, 20 something years ago, I had multiple machines sitting around. In part because I needed to have multiple machines sitting around because I needed to test out different operating
Yeah.
systems. I need to do this thing over there and this thing over there, and now you can just run it all virtually, and it's great. Um, Something we haven't touched on yet
Mhm.
that I think also factors into like the paradigm shift that containers introduce. You mentioned Docker Swarm, and there's other like orchestration type tools out there that let you run multiple instances of the same container, and you might use that for scaling. And that's the first place I encountered containers. I went to some training from Kubernetes, also known as K8S, because Kubernetes is 10 letters long with a K and an S. And someone decided that that was a good idea. But it's an orchestration platform that basically says you have like rules around your which Docker pods to spin up,
Mhm.
when, and what circumstances, and where you can really find benefit of this kind of thing is, let's say you have a service that runs in local, it could be on a bare metal server, it could be virtual, it could be a container or whatever, but you know that you're going to have like a spike
Mhm.
in user traffic. You can have rules set up to spin up a bunch of instances of your container. So now you are running them. It's the same environment. It's just you have more places that you can that can handle the load. And then when the spike goes away, it shuts down. So you're only paying for like while it's running, and and you're able to get scale at the same time.
Yeah, I mean, isn't that essentially like the SaaS? It's software as a service, as opposed to like like you said, bare metal computer. I install an application, I run the application. Like there's so many use cases where that's overkill, and instead spinning up when you need it on Google Cloud or Amazon Web or Microsoft Azure or whatever, when you need it, do the thing and then spin them down. It's it kind of goes back to one of our previous episodes where we were talking about the problematic tech talk, that it's like moving away from considering computers as pets that we name, that we
Mm.
nurture, that we care about existing for as long as possible, versus cattle, which are just a computer that's really just like a quick little thing that spins up, does a thing, and then goes away when it's not needed anymore. That we don't name, that we don't nurture, that we don't care how long it's been there. It's just there for a thing. It does the thing, it goes away.
Yeah, containers are definitely cattle. A virtual machine would be more like a pet.
A little bit, but still, it's something that like it's not the same as the bare metal machine you're running on, which I gave a name, which I
Mhm.
care about keeping it updated, that I keep about, I want it to last as long as possible. Virtual machines somewhere in between containers, but yeah, I get what you're saying. It's psychologically, it definitely changes the way that I think about what a computer is. When
Yeah.
when I first started using computers, I thought about it as this big gray box with that was huge and had a bunch of stuff in it, and the monitors that connected to it and the keyboard and mouse that connected to it. And now a computer is, it can be so many different things, and you may, like I said, it could be ephemeral. It could exist for a little time and then goes away, but it's still a computer, isn't it? I don't know. Like, is that
Yeah.
even the right term for
But now
these
you've
things?
got a whole bunch of computers at the same time.
Yeah,
Yeah.
I'm just, technically, obviously, it's different, but I think I'm just saying that it also changes our psychology about what a computer is. I mean, I remember when iPads came out, and that advertising thing that Apple did at some point, where like a little girl is like playing with the iPad, and someone mentions the word computer, and she's like, "What's a computer?" Like, because an iPad, like for my daughter, an iPad is as much a computer as the Mac that's behind me that she uses sometimes.
Yeah.
And that's the same as like something you spin up in the cloud to run a process and then shut down and never look at again.
Yeah, it's funny when I was in college, when I first went in for my computer science degree, for the most part, it was just early enough where a lot of people didn't even have internet access at home,
Mhm.
like I did, because I'm a nerd and I was ahead of the game
I
on
was
that.
gonna say it, but
But
I knew you would say it. So
but a lot of people didn't,
yeah.
and some people didn't even own their own computer. So what you did is you'd go down to the computer lab, and there was a mainframe,
Hmm.
and then you had dumb terminals
Hmm.
on your side of things that just connected to that and basically opened a shell session
Hmm.
uh, to that machine. But everything was running over there. And in a lot of ways, I feel like we went away from that as internet became more ubiquitous and everyone started having computers at home. And, we've got all these devices that effectively are computers. But containers, in a lot of ways, I use in the same way that I view like a lightweight client. A thin
Hmm.
client is the term for that usually, or a dummy terminal. Right? I go there and I'm like, I want this thing. I just need it right now, and then I do my stuff, and then it goes away. And you can load that effectively anywhere. It can be running on my machine. It could be running on your machine. It could be running in the cloud.
Hmm.
I don't even need to know.
Yeah, it's like it doesn't matter. Like it's immaterial where it's running. It just needs to run and do the thing. It's amazing how in our lifetime I've seen computers go like from the big gray box to that. And I'm trying to imagine like am I still going to be using a computer like I do now, or is there some future where we go back to the dumb terminal and everything runs in the cloud because that's where all the resources are? I don't know if that's going to happen, because I feel the thing with like everything going from like everybody has music like MP3 files on their computer to everybody just using Spotify. Everybody does not have videos that they're watching locally. It's all on Netflix and stuff like that. I mean, it's like we moved from the dumb terminal mainframe to everything's local to kind of back to the other way. And it's like, will it come back the other way again? I don't know.
We've gotten way off topic, but that reminds me of something that I've always wanted to see that has not happened yet, which is I think my phone should effectively become a hard drive, right? That anywhere I go, any machine I'm on can be a dumb terminal, and I plug this thing in,
Mm,
and it's got all my files.
hmm.
Although now you've got the cloud can be that thing instead,
Yeah.
but it's got all my files. It's got my settings. It could effectively have my container on it that I go click plug, and now I can just run it on whatever hardware I'm
Yeah.
on. And this is just a device that stores things, and the cloud obviates that. It's like I don't even need that.
Yeah.
I just need a dumb terminal somewhere. Um, and I could see a world. I don't know if this will happen, but I could see a world where the systems themselves get lighter and lighter weight. Like if you look at a Chromebook, it already does
Yeah.
this, where it's effectively nothing on there, and you're connecting to your cloud. But if you went to a different Chromebook and logged in as you, I think you more or less get the same environment.
Yeah. And you're right. We are getting quite off topic, but I feel
But
like
it's an
the
interesting topic.
to bring it back around to containerization, it's just
Yeah, put it back in the
yeah,
box,
we're
Mike.
so if we put all this back in the box, the box is that the box used to be a big gray PC box or an even bigger mainframe. Now that box is virtual. But you using your phone as an example, or us using the cloud, it's just everything is put into that box, and that box can go anywhere. You are not constrained to your bare metal physical computer that you're using. It's like a computer can be so many things and be anywhere, and that's how it is now, and that's how I don't see that going away. I don't see us going back to big gray boxes in our house. And that's why I was saying it feels like a paradigm shift that it's I've been in it so long that it just seems normal, but I know it wasn't always like that. I think I mean, it's exciting. I mean, I love that Docker exists. I love that containerization and virtualization exists because it makes everything so much easier. So I wouldn't want it to go away. But I just, like I said, the psychology of what computing is, like, maybe we can't predict it, but it's definitely changed even in our lifetime, and I think will probably change again. And containerization and virtualization has a lot to do with that, I think.
I agree.
So, excellent.
All right, let's pack it up.
Okay, we're ready to ship it. This episode on containerization has been brought to you by Hacking the Grepson. If you want to get more of these discussions, we have several other digital boxes full of discussions at hackingthegrepson.com. We try to put an episode out every other week on Wednesday. But until the next one, we now return you to your regularly scheduled lives already in progress.